of the test plane. And to support all this project, we use an online simulator called SPEMIS. It's the developed by the European agency, the ESA. And this online platform helps us to know the values that we will to replicate with the simulator. For example, we have here a simulation of 5 orbits of a lower orbit with an altitude of 600 kilometers and an angle of 60 degrees. Also they give us the graphic of the irradiance that receive the photovoltaic panel during this period of orbit. And also we can see, for example, here, the dynamic that we required on our simulator. And to get this, that the user can control this simulator, we propose a control scheme. You can see we start with the graphic user interface, then a microcontrol unit. The microcontrol unit gives the information to the motors, but first they need to supply with a power stage. And during this period of simulation, we have sensors that measures the parameters during the period of simulation. I have mentioned it in the past slide. We want to know about the voltage, the current, the temperature, and the irradiance. And the last step was to design the graphic user interface where the user select and determine the conditions that we have to simulate the photovoltaic panels. For example, we have here different options. One option was to have ion conditions. When we select these ion conditions, directly we establish the level of irradiance. You can see here we have, it depends on the ion condition, we have a certain level of irradiance. Also, when we select this condition, we know the angle of the orbit, and at last we can select the number of orbits that we want to simulate. Another case was to select the level directly of irradiance and the angle of the orbit, and also the number of the orbits. And the last case was to select the angle and the altitude of the orbit, and also the number of orbits that we want to simulate. And here on the right of the graphic user interface, we can see the real positions. They show us the position during the period of simulation, where is our satellite during the period of simulation. Here we can see the voltage, the current, the radiance, the pressure, and the time lapse during the period of simulation. There are real-time values. And I start a little simulation. For example, and here at the right we have the simulator and what happened during the period of simulation. I start the simulation. We have, for example, here a polar orbit, and the simulation gives us during this period real values during the period of this simulation. And we can see how it moves the satellite during this period. We have here a video taken on one of the tests during the development of this project, and we can see how is the dynamic and the motion that has the satellite. We have here an angle of 13 degrees, and here at this moment we have a halogen lamp, but the purpose is to make the array of lamps to cover as better as possible the spectrum of the sun. And also we can see here the partial shading effect that we make by having an angular motion in where is the photovoltaic panels. And as conclusion, I can say that the proposed simulator has the desired dynamic during the period of simulation. Also, that the simulator is capable to cover specific cases of irradiance, not only AM cases. Also, the light is capable to have higher level of irradiance. The proposed simulator is a low-cost simulator, very useful for universities or institutions that have a low budget. At the end of the simulation, the graphic user interface is capable to give a final report of the performance of the photovoltaic panels. Also, in addition, I can say that the light source is capable to cover more than the visible spectrum, that we know that the photovoltaic panels works in the visible branch of the electromagnetic spectrum. But when we add this other electromagnetic spectrum, we make that the simulator is more a real case that the only characteristics that have the sun that emits and that's happening in space. And well, if you have any questions, we'll know more about this project. Here's my contact information, or at the end of the session, I give you my presentation. Thank you.